No.
Deepika, Kumari Vandana, Preeti Singh, Sapna Chaubey, Shantilata Gudia. Please turn on your audio and join with audio. Otherwise, you cannot hear. Preeti, Sapna, and Shantilata. Yeah, Shantilata has done it. Sapna and Preeti. So electromyograph, again, electromyograph is an instrument that is used for recording the electrical activity of the muscles to determine whether the muscle is contracting or not, or for displaying the action potentials spontaneously present in a muscle in visual and audible form, or those induced by voluntary contractions as a means of detecting the nature and location of the motor unit. Okay, now motor unit, we will come to that, that what is a motor unit. And this, as the second point, you can see that to produce a record is called an electromyogram. So let it be very clear, electromyography is the technique for evaluating and recording the electrical activity produced in muscles. Electromyograph is the instrument used for electromyography, and this electromyograph produces a record that is called an electromyogram. Okay. Now again, these EMG measurements are also important for this, for the myoelectric control of the prosthetic devices, that is artificial limbs. There is an example of prosthetic device. Now this use involves picking up electromyogram signals from the muscles and at the terminated nerve endings. Every muscles is connected to our nerves, I mean brain. So in the brain, I mean whatever the neuron is, I mean nerve is going through all of the organs, through all over the body. So these nerves has some nerve endings. So these potentials picks up the potential from, I mean this technique picks up the potential from the nerve endings. So the resting muscles will be there. So resting muscles doesn't show any recordable electrical potential. But with the increase, this is very interesting, that with the increase of force of contraction, amplitude of potential increases. Like you are resting, then the electromyogram record will show no potential. Okay, but whenever you are, I mean, whenever you are running, or you are doing some exercise, you are doing some work, physical work, then it will produce some electrical phenomena and it will be recorded in the EMG. And this electromyograph, it actually detects the electrical potential generated by muscle cells when these cells are electrically or neurologically activated. Electrically activated मतलब कुछ shock लगा तो इसमें muscle contraction होगा, ठीक है? और neurologically activated means you are doing some work, or any mosquito bites, any work, any physical exercise, this kind of thing can also generate the electromyograph potential. Okay, so here we go with some other terms also. What is motor unit potential? You need to know that before, I mean, while discussing the electromyogram or electromyography, we need to know that what is motor unit potential. This motor unit potential is the sum of action potentials produced in the muscle. Okay, now you can ask that human body is having a number of muscles, ample amount of muscles. You need, I mean, you cannot count. Okay, these electromyograph, again we say that whenever we are measuring some electrical activity in brain or heart or muscle or blood, anything. So this uh, needs a subject of interest within a specific area. Okay, likewise you can, if you can remember the measurement of pressure, blood pressure, we need to use the handcuff within the peripheral artery, I mean around the peripheral artery. Okay, so here also we need to take the reading from a particular area of the body. Okay, like if we can consider our wrist. Okay, just above the wrist, you know, the position between the wrist and the forearm, there is a position of muscle. Okay, so that muscle, I mean that particular area is for using this, is used for the measurement of this electromyogram. Okay, now this motor unit potential, this only gives the sum of the action potentials on that area of interest. Now this motor unit potential is characterized by its duration, number of phases, amplitude and rate of rise of first component. We will come to that. Now duration means, that means during which time, how much time this potential is active. Okay, and there should be some phases will be there while measuring the motor unit potential. There should be some amplitude, because everything we are measuring in the body electrical activity, whether it is heart, brain, muscle, anything, so it will give some output in electrical quantity, maybe in some millivolts or microvolts. So in presenting those electrical quantities into its equivalent graphical form, we need to use sinusoidal waveform. Okay, so this sinusoidal waveform, this is represented by the electromyograph also. This have some amplitude. This waveform must have some amplitude and must have some frequency. Okay, so frequency is nothing but the duration, inverse of duration. Okay, and the rate of rise of first component. Now just compare, just imagine that you are having a rubber ball with you, that is used for playing cricket. So if you drop the ball from a certain height, what will happen? What will happen if you drop the ball to the ground?
It will bounce back.
It bounces
ball
back.
shape may be changed, sir.
That means first you drop the ball, then it will come like, I mean it will rise to some height, it is get dropped and it is rises to up to some height. Okay, उसके बाद क्या होता है, धीरे धीरे वो ड्रॉप करते उसका जो राइज हाइट जो जितना आ रहा था वो कम होते वो एकदम रेस्ट में चला जाता है, ग्राउंड पे स्टैंड स्टिल हो जाता है. That is the phenomena of us whenever you drop a ball, whether it is rubber or plastic, whatever. Okay, unless the Deuce ball drops, every ball will follow this same phenomena. Is it right? So you can see that the first drop is the maximum. After dropping in the ground, after touching the ground, it bounces back to a certain height, and after that the rising height falls. धीरे धीरे वो जो उछाल के जो ऊपर आ रहा था वो नीचे धीरे धीरे कम हो जाता है. Okay, so that is why these first pulse should be noted. Okay, that is why here also written that rate of rise of first component. Okay, so like if we draw the graph like this, first action potential, suppose it is having some resting potential that is slightly lower than the zero, slightly lower, so it will rise like this. Okay, and go on like this. Clear? Is it clear?
Yes, sir.
So this will be the potential and this will be the time. Okay, so this is sinusoidal in nature, so please bear with that, because while pointing in the PPT I cannot draw exactly same. So this is the rate of rise, this portion. I need to use some other just a minute, otherwise you cannot understand. Now this is the rate of rise. That means suppose this time duration is T1 and this rise is represented by V1. So the rate of rise will be V1 by T1. So this is characterized by this also, this motor unit potential. Okay, any questions? Okay, if you are having, I mean, you have, I mean, you get the questions after this also, you can ask. Okay. So there are some standard readings of electromyogram, that is the pattern of EMG that is recorded and findings, just like the blood pressure thing. That pattern of EMG is the resting activity. Okay, so when it is recorded, now I mean how and when it is recorded, the resting activity of the muscle, then when the muscle is relaxed and needle is not moving. Okay, so this is the resting activity, so no electrical potential will generate, so findings is no activity. Okay, now insertion activity. Now needle is moved to the various sampling spots within the insertion tract. Let me tell you that one thing I have missed, that the this kind of electromyograph is nothing but the invasive technique. Okay, because some needle is to be inserted inside the body. I mean, not inside the body, I mean through the skin. The needle should be inserted through a tissue, into a tissue. Okay, so needle is moved to the various sampling spots within the insertion tract. Okay, and now brief action potential. So few, I mean a very small electrical response have been received from the human muscle. And now next is motor unit potential. This is the area. This is very important. Needle is not moved while patient makes slight contraction. Needle is fixed, but the patient patient is moving. I mean, not moving when at the point of the needle insertion, this muscle contracts. Okay, so what happens? A few motor unit action potentials, biphasic or triphasic, short duration. You need not to know biphasic or triphasic. So it is having two phases at a time, three phases at a time. This is very complex kind of thing. You, I mean, you need not to remember this thing. Only thing is, whenever the needle is moved while the patient makes slight contraction, patient means the point of interest जहां पे needle लगा हुआ है वो muscle को contract होना है. So as a result, some action potential will be there in terms of motor unit action potential. Now the final pattern is recruitment of EMG. That means the subject makes progressively stronger muscle contraction until reaching the maximum force. So maximum force means maximum contraction. Maximum contraction means maximum action potential. So the findings is increased number of functioning movements until the baseline is obscured. Okay. So there are 4 activities. At first, there is no activity, there is 0. Then brief action potential. Then considerable one, that is motor unit potential. That is, for a healthy body, this is very important. And recruitment, that means if a severe muscle contraction occurs, then only the number of functioning movements, these action potentials reach its maximum value. Okay. So what is the maximum value, minimum value? We will come to this. Now there are some features of motor unit potential also, as we are discussing in the earlier case, that there is a duration. You can remember these 4 points: duration, number of phases, amplitude, and rate of rise of first component. We will go to that slide. You can see there are 4 features of the motor unit potentials are there. Number 1 is measured from the initial duration. From where it is measured? This is measured from the initial takeoff to the point of return to the baseline. Okay, just like if the action potential is like this, if this is the baseline, this is denoted by B. So if the potential rises here, like this, then the duration will be from this to this. Okay, this will be the duration. Clear? And typically this value of this duration is 5 to 15 milliseconds. Okay. Now phases, as we have discussed, that is somehow difficult to understand. That is biphasic, triphasic is there, not monophasic. Monophasic is you know that what is monophasic kind of waveform. So the portion of the motor unit potential between the departure and the return, that is the departure. This portion is the departure, and this portion is the return to the baseline. Portion of the MUP between the departure and the return to the baseline. So this is triphasic, positive, negative, positive, anything. And polyphasic MUP with more than 4 phases. Okay. So you need not to remember these 2 points. You just remember this one. Okay. If it is asked that what is the feature of motor unit potential, you can write it. So now the amplitude. So this amplitude is measured from the maximum peak of the negative phase to maximum peak of the positive phase. Clear? Now just like measuring the amplitude of a sinusoidal waveform, that is same. Okay. And typically the value of this amplitude of this motor unit potential, that is 0.5 millivolt to 2 millivolt. Okay. And this rise time, duration from the initial positive to subsequent negative peak. Okay. So now this rise, whatever we have seen, that from the negative one, the action potential started rising up. So this is V1. This was denoted by V1. This is T1. So rate of rise of first component is like this. So this value is normally below 500 microsecond. Okay. So obviously the rise time should be very less than the duration of the motor unit potential. Please keep in mind, don't write 500 microseconds. That will be greater than the duration of the motor unit potential. Okay, so the rise time must be below, when far away below than the duration of the motor unit potential. Okay, please keep in mind. Now there are some factors that affects the motor unit potential, that the technical factors are there and physiological factors are there. So the technical factors that includes that affect the motor unit potential, that are type of needle electrode, characteristic of recording surface, electrical characteristics of cable, preamplifier and amplifier, method of recording. We will come to the block diagram of electromyograph EMG, and then we will understand that what are the blocks included for measuring the electromyogram. And there are some physiological factors too, that age of the patient is very important, muscle examined is very important, and temperature is very important. Is it clear now? So there are technical factors and physiological factors that affect the motor unit potential. Now, as we have discussed that, do you have any question up to this? You can ask.
Hello? 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 हेलो
हाँ गौतम, बोलो बोलो, सुनाई दे रहा है.
गुड मॉर्निंग सर.
हाँ बोलो.
सर सर ड्यूरेशन में जैसे कि वहाँ पे जब ग्राफ बनेगा सर, तो वो पॉजिटिव नेगेटिव दोनों हो रहा है सर. तो राइज टाइम उससे बिलो, हमेशा बिलो ही रहेगा सर.
राइज टाइम उससे बिलो होने के कारण
मतलब वो हमेशा फिर बिलो ही रहेगा सर. वो जब ग्राफ जब ड्यूरेशन का नेगेटिव हो या पॉजिटिव होगा तो बिलो होगा सर, लेकिन जब नेगेटिव होगा तब सर.
एक्चुअली लास्ट वाला जो तुम बोल रहे हो वो समझ में नहीं आ रहा है. नेगेटिव वाला क्या, पॉजिटिव वाला नेगेटिव वाला क्या बोल रहे हो
सर? डिपार्चर टाइम से जो बेस लाइन पे जा रहे हैं ना सर हम लोग,
हाँ,
तो हम लोग पॉजिटिव साइड, ग्राफ के पॉजिटिव साइड एक्स वाई पॉजिटिव में जा रहे हैं फर्स्ट कोऑर्डिनेट में.
जैसे कि अगर हम लोग एक मिनट इस डायग्राम पे देखें, देयर आर सम पॉजिटिव पीक आल्सो, नेगेटिव पीक आल्सो.
नेगेटिव. हाँ, जब नेगेटिव होगा सर, तो जब नेगेटिव होगा सर तभी राइज टाइम लो रहेगा सर, बिलो रहेगा सर.
देखो बात ये है कि फर्स्ट जो राइज टाइम है, that is from negative to positive, that is the rise time. That means if we also draw like this, तुम लोगों का कंट्रोल सिस्टम्स, ऑटोमेटिक कंट्रोल सिस्टम्स एक सब्जेक्ट था ना?
इलेक्ट्रिकल का सब्जेक्ट था सर. हाँ सर.
You know this kind of graph?
हाँ सर. सैचुरेशन.
That means this is called the 90% of the, sorry, this is somehow
एक्टिव रीजन.
so this is the 90% of the peak. Okay, so to reach from the initial value to the 90% of the maximum value is called the rise time of an waveform. Okay, this kind of waveform. And similarly there is fall time too. There is a fall time too. So here again, from the 90% of the peak value, time taken to reach the zero value or base value is called the fall time. That is denoted by TF, and this is denoted by TR. Can you remember?
Yes sir.
So this rise or this fall, whatever, that can be from anywhere, positive, negative, anywhere. That doesn't matter. The matter is only that you have to take, or the electromyograph, while recording the electromyogram, then we need to consider only the first component. Okay.
Okay, sir.
Okay. So, any other questions? So, any other questions from your side? Okay, I suppose there is no such questions. So, there is near about 8 minutes remaining. So, I don't want to start this kind of thing, because there is a block diagram and operation is there, and applications is also there. So, I think this would not be completed by today's time. So, if you are having any questions on today's topic or previous topic,
Sir,
yes.
sir, hello sir. Good
Mm-hmm.
morning sir.
Yeah, good morning.
सर ये जो EMG है ये तो मतलब मसल्स का एक रीडिंग लेते हैं सर, एक होता है EEG, तो सर दोनों में सर किस टाइप का रीडिंग्स ये आता है? जैसे EEG होता है तो सर वो तो ज्यादातर आपका जो नर्वस सिस्टम होता है उसका इलेक्ट्रिकल जो सिग्नल्स होता है उसको मेजर करते हैं.
You are right. So EEG is nothing but electroencephalograph. Okay. So
Yes sir, yes sir.
encephalography is exactly means the electrical activity of brain. Okay. So in other
तो
terms,
सर वो
the unit.
ओनली मतलब वो ब्रेन का एक्टिविटी को वो मतलब मेजर करेगा.
Right. We will come. I mean, we will discuss in the next week itself, because from next week we have to start the. I mean, this is a very broad topic. I mean, the most broad topic was the heart activity. Then it comes
सर
the brain
रेस्पिरेटरी
activity.
सिस्टम.
Respiratory system में भी आएंगे, because this recording system should be there. So you will communicate between the differences between ECG, EEG, and EMG, because this is the very important questions that comes into your university examination, and this is a very basic question. And nowadays you people know that medical science will go, I mean, I don't know where is the end. So some research and some advancement should be there to record this kind of electrical activities. As you have said that this is the this EEG is nothing but the measurement of I mean, nerve activities. So we will discuss it again there also in the next week, that this brain is full of brain is the head office of the nerves. Okay, it gives some information, receives information, process informations according to the application, and according to the response received, and it gives the information to the nerves, and the unit of the nerve is nothing but a neuron. Okay, so we will discuss it later on also, that what is neuron and what are the functions operated by the neuron, and many other things will be there. Yeah, Kumar Gaurav.
Yes, sir. Sir, in the starting of the lecture, you said human muscles is having a property of electrical electrical property of for reacting, in which we record in electromyography EMG. Sir, I want to ask that how the conduction is taking place between the muscles. As we know that in neurons, it is done by the tendons. The electrical impulses conduction is done by the tendons, and the property we know the basics. But how it is conduction is happening in the muscles?
Look, this electrical activity, whenever there is a cell, there will be an electrical activity. Whenever, I mean, kahin pe bhi ho, if it includes some cell, then it will produce some electrical activity. Now coming to the electromyograph. In electromyography, electrical, physical का तो कोई problem नहीं है. Physical activity is normal. Whenever some electric shock is given, I mean not like the 3-phase or single-phase shock. Some electrical shock should be given to the EEG phase, I mean heart-related activities. If you can remember, the heart rate, the rhythm is generated from the sinoarterial node, SA node. So if this SA node got defected, or it is not producing some electrical quantity, producing some random pulses to the heart will not function properly. So what is there? You know that we have discussed about we have shown a video too of the cardiac defibrillator. There we put some shock into the human heart, and the contraction and the expansion of the heart activity will be resumed. Now the shock is given to the heart, तो heart के ऊपर तो हम लोग directly defibrillator को नहीं लगा सकते. We are placing the defibrillator onto the chest. ठीक है? So there are some chest muscles. तो वो shock वो muscles के अंदर से ही जा रहा है to the heart. Okay? तो हम लोग चेस्ट में लगाते हैं क्योंकि चेस्ट में मसल बहुत कम होता है. यहाँ पे जो होता है that is ribs. Okay, so there are hard bones, nothing else. So there may be some electrical activity by giving some external electrical shock. Otherwise कोई किसी को अगर electrical shock लगता है accidentally, then what happens? His muscle stiffens. कभी भी तुमको अगर इलेक्ट्रिकल शॉक लगा है छोटा मोटा, तो you should know that there are muscles contracts immediately. ठीक है? तो ये contraction की वजह से पोटेंशियल जनरेट होगा. मोटर यूनिट पोटेंशियल इस तरह से जनरेट होता है इलेक्ट्रिकल पोटेंशियल इन द ह्यूमन मसल. You got your answer or
हाँ सर, इसमें जैसे कि गौरव जी तो बोल रहा है सर.
बोलो 2 जन बोलने से नहीं होगा, 1 जन बोलो.
नहीं सर, मेरा बोलने का मतलब है कि सर जैसे कभी भी शॉक लगता है तो सडनली बहुत जोर का झटका लगता है, तो मसल्स के बीच मतलब कंडक्टिविटी होगा तभी तो मतलब इतना ये होता है, रैपिडली एक्शन होता है.
डेफिनेटली वो इलेक्ट्रिकल जो मतलब जो भी इलेक्ट्रिकल एक्टिविटी फ्लो होता है थ्रू द मसल, obviously this will be through the neurons. Obviously नर्व जब रहेगा तो उसमें न्यूरॉन भी रहेगा. ठीक है? बट दिस इज नॉट मैंडेटरी, बिकॉज किसी मसल्स में हो सकता है कि वो न्यूरॉन ना हो. ठीक है? जैसे कि हमारे नाखून में कोई नर्व्स का कोई सेंस नहीं है. ठीक है? तो इसीलिए हम लोग अगर नाखून पे कोई चोट पहुंचता है, नाखून अगर काट भी देते हैं तो हम लोगों को कोई दर्द नहीं होता. ओके, सो वी आर नॉट हैविंग एनी न्यूरॉन्स इन आवर nails.
Okay, sir.
Okay, so only less than 1 minute is showing this software. So we will meet tomorrow and we'll end up this EMG, and from the next week we will start the EEG. Okay, thank you so much.
Thank you, sir.
Thank you, sir.
Thank you, sir.